Hey everybody, it's Mr. Oaks. So we're going to talk today about determining the number of solutions for an equation. So most of the time when we solve an equation, we get an answer. We get x equals some number. So we get one solution. But we can actually have situations where we might be able to actually see that really any number we use is going to work. And then there are going to be situations where no number we use is going to work. And we can figure this out by either kind of going through it and trying to solve the equation and getting to a point where you kind of either get an x equals or something else happens. But usually we can actually figure this out much sooner, whether we should continue trying to solve it or not. So we're going to talk about each individual situation and how to determine, without having to solve it all the way, whether we're going to have one solution, infinite solutions, or no solution whatsoever. So first we're going to go and talk about the one that you normally see, which is one solution. So when we have one solution, we're always going to look at, when we try to figure out the number of solutions, we're going to look at two things. We're going to look at the coefficient, which is the number that's in front of the variable. But then we're also going to look at the constants, which is the numbers that are not attached to a variable. They're usually the number that you're adding or subtracting. And what we want to do is we want to kind of get each side of the equation to just be one variable term and one constant term, so that we can kind of compare both sides. So the first one here, one solution. Now one solution, we have different coefficients on each side of the equation. And so what we have to do is kind of work and do, if there's something going on such as a distributive property, or we have like terms on the same side of the variable, we need to get those and simplify it so that we only have two terms on either side of the variable. So when we look here in our example, we have 7 times the quantity 2 plus 5v equals 3v plus 14. So we have distributive property. So what we're going to do is we're going to get rid of the distributive property and hopefully have two terms on the left-hand side. We already have two terms here, 3v and 14, but now we want to go and simplify the left-hand side. 7 times 2 is 14. 7 times 5v is 35v. And that equals 3v plus 14. So now when I look at this, I notice my coefficient on the left-hand side is 35. My coefficient on the right-hand side is 3. Now those are different coefficients, so that when I go and I subtract my variable term, more likely than not the 3v, from both sides, I'm still going to have the variable. So I know that this is a one solution equation because I'm still going to have at the end that the variable is going to equal some number. Now I can actually go and continue to solve this and figure out, well, what is the answer going to be? So I go through my questions. I already said, oh, I have distributive property, I take care of distributive property. I don't have fractions, I don't have like terms on the same side of the equal sign, but the variable is on two sides, as I pointed out. So now I can subtract it from both sides. Minus 3v minus 3v. We get 14 plus 32v equals 14. I want to get rid of this constant, so I'm going to go and subtract 14 from both sides. I get 32v equals 0. And there's really only, whoop, I dropped things. There's really only one way. There's really only one way we can get a 0. I divide by both sides on 32. V equals 0. So 0 is the only thing that's going to work in this equation to make it true. And that's the goal when you find your solution, is what is going to make our original equation true. In this case, the only thing that's going to work is 0. So that's one thing. So one solution, I have different coefficients. I can solve it and get that the variable equals some number. Now when we have infinite solutions, that changes a little bit. Infinite solutions, that's where the equation is going to have the same coefficient and the same constants on both sides. Pretty much we're going to have the same expression on each side of the equal sign. So again, we look at this. We have -4 times the quantity v plus 3 equals -5v minus 8 plus v minus 4. So we've got a lot of stuff going on there. First thing I'm going to deal with is the distributive property over here. I'm going to multiply that -4 through the parentheses. -4 times v is -4v. -4 times 3 gives us a -12. Now, on the right-hand side, we don't have distributive property, but we do have like terms. I've got this -5v here, and I've got a plus v there. So -5v plus v, it gives me a -4v. And I have a -8 and a -4. -8 minus 4 gives us a -12. So now when we look at this, same coefficient, same constant. At this point, I can look at this and kind of say, well, I have the same exact thing on both sides of the equal sign. So no matter what I put in for my variable v, I'm going to get the same exact thing. I put in 0, I'm going to get -12. I put in a -3, I'm going to get 0. I'm going to get the same thing every single time. Now what I can do still is I can kind of go and still try to go and finish solving this. So I could go and say, okay, well, let me add the variable to both sides. Let me add 4v to both sides. And when that causes the variable to completely disappear, and we're left with -12 equals -12. And that is a true statement all the time. -12 is always going to equal itself. There's never going to be any time where you go, well, that -12 doesn't equal that -12. That's always going to be the same. So this is infinite solutions because I'm always going to have this be true, no matter what number I put in. Doesn't matter if it's a positive number, negative number, fraction, decimal, square root, cube root, any type of radical. No number is going to make this not true. So in this case, it is infinite solutions. Everything's going to work. Our last situation is no solutions. No solutions is similar to infinite solutions, and a lot of students mess the two up. But there's one important difference. No solutions, we have the same coefficient, but we have different constants, all right? In a sense, we have different starting points, and then we're going up at the same rate. You can think of it as you have a car that starts 2 minutes before another car, and it drives at 50 miles per hour, and the other car starts 2 minutes later, also driving 50 miles per hour. They're never going to catch each other because they're going the same exact speed. That's kind of what no solutions is that I'm never going to have the same thing because there's different starting points and the same coefficient all the time. But let's see how that works out. So again, we have negative 3 times the quantity 1 minus 2b equals 2b plus 3 plus 4b plus 2. I'm going to start with my distributive property. Multiply the negative 3 through. We get negative 3 times 1, which is just negative 3. Negative 3 times a negative 2b. Negative times a negative is a positive. 2 times 3 is 6. So on the left-hand side, we get negative 3 plus 6b. On the right-hand side, I have a 2b. I have a 4b. 2b plus 4b is 6b. I have a plus 3. I have a plus 2. I messed up again. I didn't even look at these things. Okay? This actually should have been minus 6. I wrote it on a different one. I'm an idiot. But this is minus 6. Now, I mess up. Everybody messes up. Plus 3 minus 6 gives me a negative 3. Oh, Mr. Oakes, you should just totally do that one over again. Nope. Live with the mistake. Know that everybody makes mistakes. So we look. No, I was right the first time. Double mistake. Oh, double mistake. Negative 3, 1 minus 2b equals 2b plus 3 plus 4b plus 2. You sometimes forget why you're doing these things. Multiply it through. Negative 3 plus 6b equals oh, 2b plus 4b, 6b. Then plus 3 plus 2 is a plus 5. Now when we look at this, and I'm paying attention and my brain isn't trying to fix things, I have the same coefficient, positive 6, but our constants are different. This is a negative 3, this is a positive 5. There's nothing I'm going to multiply 6 by that is ever going to be the same if I take away 3 or I add 5. Think of it this way. If you and a friend both have $6 and someone takes $3 away from you but gives $5 to your friend, do you still have the same amount of money? No. It's different amounts now. So that's why this is no solution, because there's never going to be some time where this is going to be saying, I put 0 in here, not going to work. I get negative 3 equals 5. As a matter of fact, if I subtract 6b from both sides of the equation, we're left with negative 3 equals a positive 5. That's just not true. That's never gonna be true. There is no point where negative 3 is ever gonna equal a positive 5. So that's how we do one solution, infinite solutions, no solution. One solution, our coefficients are going to be different. We can solve for whatever the variable is. Infinite solutions, we're going to have the same coefficient, the same constant. We have the same thing on both sides of the equal sign. It's always going to be true. Infinite solutions. No solution, different, I'm just going to keep messing up on no solution. Same coefficient, different constants. I have it going up at the same rate, but the starting point is different. So I'm never going to have the same thing. With the exception of that last one, I hope most of this was helpful. You. If you have any questions besides, why'd you lose your mind on that last example, Mr. Oakes, please feel free to post them. Like, subscribe, don't like this part, but like and subscribe, and I hope I'm able to help you most of the time. Please, never be discouraged by math. Always look for the pattern. I'm Mr. Oakes. I probably need to go to bed. I'll see you in the next one. Bye-bye.